So this is my project, part one of my project for cs5260, which was AI for a trading game, where you can have a configurable set of countries, a configurable number and type of resources. There's a base set of transformations which you can add additional transformations to. So the transformations, a country can transform its own resources from one thing to another, but there's also the possibility of trading resources, that you can, one country can transfer resources from itself to another country or from another country to it. And part one of this project just generates one round of moves for a country. Presumably in the second part we will make that go in rounds with different countries. My implementation is in Haskell, which is a functional programming language, very common among functional programmers. It's known for lazy evaluation, and also most of its data structures are immutable. I have about 800 lines of code, and more than half of that is managing resources and doing the planning. The bulk of it is that. There's a little bit for parsing and maintaining a priority queue. Now the nice thing with Haskell's immutable data structure for a project like this is when you're doing something where you try a move and it affects the state of the world, and then you want to try a different move and you need to reset the state of the world, because in Haskell when I create a new structure, the old one still exists in its original form, and the data is shared between them, so it's not like I'm making whole copies of everything each time. They share a lot of their structure. I don't have to worry about undoing what I did. I just use the first, the original copy of something, and I just make multiple modifications to it and not have to worry about losing the original copy. So in my program, in my state quality function, what I decided to do is have right now two kinds of scoring function. And the program's written, all the scoring is loaded from a file, and I can add new types of scoring whenever I want. It takes some code changes, but not really anything in the parser. So the two kinds I have, one is a ratio that just looks at a resource relative to another resource, and right now I have everything relative to population, and so then there's a weight that is applied to that. So for instance, if I said the water in relation to population, I would take the amount of water, take the population, divide the water by the population, and multiply that by a weight. And then targeted ratio is a little different, because it's saying this is what the ideal ratio between these two items is. So, for example, if I wanted there to be 1 unit of water for every 10 in the population, I would set that ratio to be 0.1. And so what it will do is it will take the population, multiply it by 0.1, and say this is the ideal value for water to be. And anything above that or anything below that negatively impacts the score. So it's trying to make it focus on a particular value. And the nice thing about this targeted ratio is it enables the identification of shortfalls and excesses in resources, because now I know I have too much water or I have too little water. And what I did for implementing trades is that I can use this to identify this country needs this resource, this other country needs to get rid of this resource. Let's do a trade, and it's mutually beneficial. Now my scoring pipeline is essentially the same as it is in the documentation. So I have state quality, and then I compute an undiscounted reward by subtracting the current state quality, subtracting the original score for the country from the current state quality, and then I apply a discounted reward by essentially applying this gamma value over and over, and then I also have the country accept probability, and right now it's unlikely to fail. Um, the, the difference in maybe in how the documentation describes it, for my schedule probability, I accumulate that. So I have like at each new item I add to the schedule, I'm keeping track of what the probability was up to that point, and then for a new schedule item, I just multiply in the probability of that schedule element being accepted, and so forth. And as I said, it's unlikely that a schedule will get rejected because right now all my trades are mutually beneficial. I am trying to, if I need something and somebody else needs to get rid of it, I trade with them, and then we're both happy, and we're unlikely to reject that. But I do have the code in there that would give it at least a possibility of getting rejected. My search function, I have a frontier that uses a priority queue. It's bounded, so there's a configurable number of elements that can be in the frontier. And in order to do that, I actually use two priority queues, and they keep track of elements in the reverse of each other. I'm using a priority queue implementation that always pulls the minimum value. So when I'm pulling the next item, I'm pulling it from a queue in which I have stored things by the negative of their score, so that the thing with the highest score is a negative value that'll make it appear first, and then the other queue is the thing that should be tossed from the queue the next time I insert something. I don't have any smart thing that tries to maintain a balance of things with separate subtrees. It's just whatever the lowest priority thing was, it gets kicked out when the frontier size is too big. And the priority is by the expected utility. I do a best first search, so I take the next item with the highest priority. It doesn't matter where I was in the tree, and it's a beam search in that I have a limit to the number of different things I'm keeping open at the time. And also when I'm doing transforms, I calculate what I can multiply the transforms by, what's the maximum I can multiply it by, and then I actually look at all the possible transforms between one, the transform as was specified, and let's say it's 100. So I'd try 1 through 99, 1 through 100, and then I sort them based on the score they would achieve, and so then I take the top 10 best. So that might be 1 through 10, that might be 91 through 100. It could be a mixture. Like if one of them, if after 50 it started to go back down because it started exceeding some values, it may pick those. So as far as interesting test cases go, I looked at one where I was doing the Atlantis. I tried all 5 countries for variety because they have different attributes. They start with in different states. And I noticed in Atlantis, when I was doing a depth of 10 and it was bounded at 4,000, toward the end it did a trade with Dynatopia. It noticed that Dynatopia had an excess of metallic elements, and it transferred 10 of those from Atlantis. And because it was trying to do transforms based on what's the maximum that I've got, the transferring the additional 10 allowed it then to do another alloy transform because it suddenly had more metallic elements. And I didn't have anything to code for that. It just, that's how the process worked. And then another interesting test case was Dynatopia with a depth of 10. Again, the frontier is bounded at 4,000, and it transferred 10 units of electricity out to Atlantis. So it had an excess of electricity, but then it did a transform in which it created 20 more units of electronics. And I believe this is because there was a surplus of the metallic elements. And so by doing that transform, it reduced the number of metallic elements, and that more than compensated for the additional electronic units it created. In the runtime, while these graphs are just showing the iterations, what I found is that also corresponds to memory utilization and CPU. So this same spike would be in those graphs. And so with a frontier of 1,000, you can see that when it was at 4, the depth is 4, the search depth, it was doing about 85,000 iterations, and then above that it dropped precipitously and then had a little peak again and dropped off. And then I did the same thing with a Frontier of 32,000. I've actually done it in 1, 2, 4, 8, 16, and 32,000, and the numbers are all similar. The breaking point is at different places. So you can see where the other one broke at 4, this one breaks at 5, but it's doing 45 million iterations before it falls off. And this fall off, I think, is just there are branches that would cause a lot more iterations that with the Frontier Limited it's not able to process those. And as I said, the iterations correlate to CPU utilization and memory utilization. So in the CSV files I put together that are in my repo, they all spike in the same place. And it's strange that once the Frontier is exceeded, it does seem to break things, but it seems fairly consistent with that. So that's all I have.